So probability is a quantification of likelihood or chance. You could also see it as some type of a risk or uncertainty. But it's also here given a degree of belief or relative frequency. Degree of belief, yeah. Engineers don't typically use the word belief. Okay, so we'll just stick with yeah.
So in the project that we are dealing with those variables,
Yeah.
we again have to have a sample size and make them discrete anyway to do something with it. For example, let's say time. If
Yeah.
we cannot take like all the instances of time, we can take like, for example 1 second, 2 seconds.
Yeah, exactly. Yeah, so you have to pick. But if you're going to look for an optimum, and say you need to optimize the process in time, and it's easy if it's continuous. Then you can go. Okay, you've done originally 1 and 10 seconds, and you see that the optimum is somewhere between 1 and 10. You can go and look between 1 and 10 where the optimum is, and you may end up at 3.5 or something. Okay, that's what we do with continuous. In principle, you can go to numbers which are continuous. Okay, so it's in principle. In practice, of course, you have to fix it somewhere. Okay. Yeah.
What do you think about that? If you were to have something like current, for example,
Yeah.
this is a good discussion. If you're going, and let's say you've automated your sensing system, would you want to like have the system go through, let's say, all currents or all temperatures, like you can't really go randomly, right? Because you can't go from a temperature to the other randomly. You have to go through the temperature. So how do you do that? Like how do you maximize, like how do you optimize that situation where you test all like possible temperature ranges or all possible current ranges for an experiment?
Okay.
Does that make sense?
The question. Do I understand your question? Is the question? Or
yeah, like
yeah.
Yes.
Let me try to say what I think the question is. So you have some type of experiment you want to do, and you want to see what the factor current is doing. And so say that the operational range is between 1 and 100 amperes or something, and then you ask the question, do I now scan the whole range for all values? I make some continuous plot as a function of current. Or do I just pick some values and see what happens?
Well, not only that, it's like how do you get, like, so even if you were to choose randomly, let's say, say I were to measure it for 10 points, if you're 110 points,
yeah.
Like, ideally you would go randomly, right? You would just go 10, then 60, then 50, then like, but the thing is, do you do that multiple times then again, because the way in which you arrive to the point, can you assume that it makes a difference? Say I'm going from like 20 to 80 versus like going from 60 to 80. Would that affect the measurement at 80?
Yeah. Yeah, so good, all very good questions. It's like a bombardment of questions there, Shadi. Yes, how to approach that. So the way we do it here in the course, and it's of course always open for debate, so if you would want to investigate, you have a system where you have a current as a factor, and you want to investigate what the effect is of this current on the system, the way we do it here is we take a high and a low value, okay, and see if there is some significant effect to current. And say there is a significant effect, then we'll go look on this line. But typically we have many factors, so that's where the technique becomes powerful. Say we have just one factor, they would then step along this line with some step size which is reasonable, and that's all dependent on let's say the experience of the experimentator, what is the English? And so And then you would look. You would see. Okay, how does this, for instance, you start from the 1 and you step with 5 amps, and you see. Okay, it's going up, going up, going up, going up, going up, and it's going down. Okay, it should be here, and then you start stepping in between those two values where you're going from going up to going down. And you some type of numerical analogous to a numerical approach if you want to find an optimum of a function. That's the way it's done here. So, but if you have a system where you can easily ramp the current and follow your signal, why wouldn't you do it? You know? If that's the only thing you're looking at, and just take a curve and see, okay, where's it going? But here we're looking at systems which are fairly complex, and we want to be frugal in the number of experiments we're doing. And so this is the type of situation we're in here. Okay, so depending on where you are, I wouldn't say there's a one approach. Just you have to see what the situation is. What do you have as measurement systems? Is it easy? Okay, ramp. Why not? But if each data point takes you a day, you don't want to take 1,000 data points.